Before we see how TypeScript can help you, let's understand where TypeScript came from. So TypeScript was a response to how hard it is to write large-scale applications in JavaScript. So in the past, we had these large applications in TypeScript, and we didn't have like VS Codes that we have today. We didn't have Atom with all the plugins. It was, well, when I started writing JavaScript code, it was Notepad++. That's my tool back then. So we really didn't have tools to help us. And one of the reasons why we didn't have tools was because TypeScript didn't have static type information. So without this type information, it's really hard to develop tools to allow you to do refactoring or autocompletion and similar things. And static typing is what powers the modern IDEs today to have all these features that they have. So what is TypeScript? TypeScript is a superset of JavaScript that compiles to plain JavaScript. It means that basically TypeScript, if you look at the meme here on the right, is JavaScript. It's just disguised. The only difference between JavaScript and TypeScript is that TypeScript has type annotations. But all those type annotations that you have in your code are stripped off when you compile to plain JavaScript. The end result is going to be you're going to have JavaScript code. TypeScript does not have a runtime. It doesn't run anything for you. It's just a tool that transforms code with type annotation into code. TypeScript is multi-platform, so it runs on any browser, any host, any operational system, because it's JavaScript. And it's open source. So Anders is a fellow at Microsoft, and he said, TypeScript is an answer for the cry for more productive JavaScript development tools. So the reason for TypeScript to exist today is because we lacked tools to help us develop things in the past, and with TypeScript, we get all those tools today. So TypeScript is not a religious affiliation towards adding types to everything. Like TypeScript allows you to code however you like. You don't have to force everything to have a type. TypeScript is not bringing back bad object-oriented practices from the 90s. So you might have heard that TypeScript has JavaScript. No, sorry. You might have heard that TypeScript has classes, but TypeScript doesn't really have classes. JavaScript has classes. If you look at the documentation on MDN, you can see that JavaScript has classes. TypeScript is not trying to add new features to JavaScript. In fact, TypeScript implements the proposals for JavaScript. TypeScript is not an answer to Dart or CoffeeScript. Comparing TypeScript to CoffeeScript is like comparing apples to carburetors. They are not related. CoffeeScript is a syntax sugar. It's a different syntax that transforms into JavaScript. And TypeScript is not a new language in the sense of that it's bringing a new syntax. TypeScript is JavaScript. You can get a JavaScript file, rename from .js to .ts, and that's going to work. You might get some errors because you're doing something wrong. Otherwise, if you have everything correct, you're not going to get any errors. You can just rename your files. What I like to do, so Anders also said, what I like to do is build programmer productivity, bottle it, and sell it. So what he likes to do is just help developers get shit done faster. So types on or off? Why not both? So TypeScript has all these options. that allows you to configure how much you want to be strict or how much you want to relax the settings. So Anders also said that you can dial it all the way to 0, or you can dial it as high as you want. You don't have to toggle switch on or off. You can find whatever works for you in the middle. You don't have to be super strict. You don't have to be super not strict. Talking about strict, TypeScript gives you strict. So you can set this option in the compiler, strict true. And this is going to catch every single thing. So here we have an example of a function that takes as a parameter a string and a number. And then basically what it's doing, it's checking if my input on the screen can have more text or if I hit the character limit. And then it's saying that this function should return a Boolean. But if we look at line 2 where the code is, we are checking if there is text, and then if there is some text, we check for the length and compare it to the limit. But if we don't have text, if text is null, this the right-hand side of the operation is not going to execute because it's an AND operation. So the left side is going to fail, and the end result is going to be that it's returning null. But null is not a Boolean. Boolean is either true or false. Cannot be undefined, cannot be null on strict mode. So that's why you have an error here. One way to fix it would be to kind of cast text to a Boolean. So you could have two not operators before text, and that would convert text to either true or false. And the second part here would evaluate to either true or false. So that's a way you could fix this in strict mode. But you can also just not be that strict. So if you look at the picture here, strict is like, oh, okay, I will do everything correctly, 100%. Or you can opt for some more freedom. And then you can just say, yeah, I know what I'm doing. Thank you, but I know what I'm doing. Because in JavaScript, we have these concepts truthy and falsy. So truthy is when an expression evaluates to either true or false. So for example, if I have this text, and in this text I have some value, that's going to evaluate to true because the variable has value. If the variable does not have a value, if it's either null or undefined, null or undefined evaluates to false. So if you have like an if condition, like for example, if text, then do something. So if text is null or undefined, that's going to evaluate to false. You should never check for if the variable is equal null or is equal undefined. You should just take advantage of truthy and falsy. So types can be implicit. You don't have to say what the type of your variable is everywhere. You don't have to do that. You can if you want, but you don't have to. So in this example, we have this variable, which is receiving the value from another variable. And this other variable, we already know the type of this variable, which is an object that has a label and has a value. So when we create a new variable and assign to another variable, the type is going to flow through this variable into this variable. So we don't have to say, oh no, this variable is this type and it's receiving this variable that's the same type, because a TypeScript can automatically detect the types for you and it flows the type over and you have the type and you don't have to write everything. Some other examples here. So we have types for the DOM. We have HTML element. In here, we have a function that takes two parameters. Both of them are numbers, and then it returns a number plus another number. I'm not saying that what is the return type of this function, and TypeScript understands that the result of this operation is going to result into a number. So if I create a new variable and assign to calling that function, I'm going to know that the return here is going to be a number. So this variable is going to be of the type number. TypeScript gives you Intellisense. So Anders said this: I think Intellisense saves you money. It makes you productive and allows you to focus on the creative process, and that's the thing that humans brings to programming. It's not being a lookup dictionary of what's in some API. That just brings nothing to the table but time waste. So basically what happens is when you are using, in this example, Express, you have to find the function that starts the server and starts listening for requests. And you might not remember the order of parameters or exactly how to use it. So with TypeScript, you can just start typing app dot, and then you get an auto-completion of everything that's available in that app. And then with that, you can check for the functions available, and you get all this information about the function. So you can see what it does, the different parameters it takes. In this case, it has 4 different overloads. So there are 4 different ways you can call this function. You can call passing, maybe not passing a host name, just passing a port. You don't necessarily have to pass this backlog. So there are different signatures you can use. So you got all this information here. You don't have to stop what you're doing. Go over your browser, Edge, Chrome, whatever. Find the documentation for Express, and then find the page where it explains how to start the server, to find the function you want and see how to use it. So all this effort that we had in the past, having to look up APIs everywhere, documentation, how to use things, we don't have to worry about that anymore, because TypeScript improves our agency. We are more productive. We don't have to waste time doing all of that manually. We have all the information that we need right here, available right now. So Intellisense is intelligent code completion. Basically, it's not just an autocomplete. Of course, like it gives you the autocompletion, but it also gives you information about the thing you're trying to use. In this example, the folks at Material UI, they documented on how to use color, and they are saying which one is the default value. So you know, if you try to use a text field, the color is going to default to primary, and you can use some different values in here. And this color is typed, or might be typed. So you get an auto-completion of all the available values that you have in that. You can have that. Intellisense on packages. So nearly every popular package in NPM either has TypeScript types built into them, meaning if you install a package, you automatically get all the types, all the auto-completion and everything else. And some packages, they don't, but they have an equivalent types if you install add types / the package name. So if the types are not maintained by the package owners, it's going to be maintained by the community. There's a really strong community on GitHub called Definitely Typed, and they have like over thousands of types for packages, and they have many people maintaining those packages. So we have types for everything we want. I have many examples here. We have here Lodash. You can see auto-completion for that. We have Material UI. There's auto-completion in here. Axios, you can see when you're trying to pass a configuration, you can see the different parameters the configuration has. And I was looking for headers. So I can see auto-completion for headers. Express router, the configurations here, .env. And a fun little mention is you have types for Google Chrome. So if you're trying to build an extension for Google Chrome, you can install add types / Chrome, and then you're gonna have all the auto-completion, all the IntelliSense for the Chrome API. So you can type Chrome dot, and then you get an auto-completion. In this case here, I have Chrome.omnibox. And then I have some different listeners. I can listen for a few different events here, and I can set the default suggestion. So you get all that auto-completion even for Google Chrome extensions. And you can add IntelliSense on your own stuff. So by simply adding types, whenever you try to call your own function, you can see what the parameters are and the type of the parameters and what the function returns. You can use JSDoc to improve it even further. So you can put text on, like when you're trying to call the function, it shows you this text. When you're passing parameter 1 or 2, it shows you information about those parameters. So you can have very descriptive information in here. And you can also add information on types. So you can create a type in JavaScript. Let's say we have this type person, and person has age. So if I have an object that has a property age, I can set that it's a person because this object is compatible with this type. And then when I try to use person.age, I get the intelligent information about that property. So even in your own code, you can get or add more information, so it makes it easier to work on a big team. When there are many developers working, you can share this information, and it makes it easier for developers to get things done because they don't have to read all your code and understand everything that's being done. They maybe can sometimes really easily see the parameters of a function and like really understand the function. And another example here with auto-completion for my own type. TypeScript gives you rename. So in JavaScript, nowadays on the IDEs you use, they are powered by TypeScript, so it's easy to rename things today. But in the past, like when I was using Notepad++ to code, it was impossible to rename things. Because in this example here, I have a variable called foo. If I try to rename this variable, I'm gonna have to find all the actual references to this variable because I have foo as a property name, I have foo inside a string, I have foo as a part of another variable's name, I have foo in the comments, I have foo in the part of another function's name, and there are too many references to foo, but what is actually the real reference to that one variable I want to rename? So with TypeScript and the tools we have today, you can rename a variable, and it's only going to update the reference. It's not going to update the property name in other objects or function names or comments because it knows the exact reference and it's able to rename things. And this renaming also applies to other files. So let's say that I was exporting this variable. If I was exporting this variable and using in other files, when I rename it, all the references in other files would also be updated. And that's one thing I want to talk about as well. you should avoid using export default, because when you do an export default, you can import with any name. So you do import whatever name you type from a certain file. And it doesn't have a reference to anything because it's not referencing a specific thing that's being exported. And because of that, you lose the rename capability. So if you rename what's being exported, it's not going to rename your import default because it's not referencing anything. But if you use named exports, then when you rename, everything gets renamed. So you can rename across files, and when you move files around, it can also find the references and update the references to the files. If you move, for example, in another folder level, it updates the reference if it's a relative or something like that. And TypeScript gives you the feature now. So basically, TypeScript, they decided to implement everything that's on ECMAScript when they reach ECMAScript stage 3. Stage 3 means it's not yet released in the JavaScript that we have today on our browsers, but it's going to be soon because it's mostly approved. You maybe just have some minor changes. And so here we have an example. Optional chaining today, it's you can run on your browser. If you open your browser and try to run this code, it's going to work. But in the past, when this was not yet released, we had access to this before we had in JavaScript. So you could use features that were going to be released in JavaScript before they were released. And there's something else in here, which I haven't really tried, but you can actually connect TypeScript with Babel. TypeScript supports Babel, and Babel supports TypeScript, so you can combine both. And I haven't really tried this, but I think you might be able to get stage 0, for example, if you combine things. But I haven't tried this, so don't take my word for it, but maybe you should try. Could be fun. One of the main things about TypeScript is that you can catch errors during development time. So sometimes you're going to have a scenario where you have to authenticate, you have to add things to your shopping cart, and then you go on the checkout page and click a button, and that button adds numbers together. So let's say I was adding 1 plus 1, but as strings rather than numbers. When you try to add 2 strings in JavaScript, it concatenates the string. So the result of adding 1 plus 1 is 11. But what you actually want in this case is 2. So this might happen because you are trying to use event.target.value, and event target value is a string. It's not a number. So if you have like input type text and you type some number and you try to use event target's value, you might think that's a number, but that's a string. So you have to first convert that to a number, and then you can add them together. So in a scenario like this, maybe you would use event target value without realizing you had to convert to a number. And then you would only find out after running your application, running through all the steps to get to that specific page and clicking that button. And then you would figure out, oh, I forgot to convert to a number. And then you have to change your code and do all the process again until you reach that point to test your code. But with TypeScript, you see that error right away, because if the function is expecting a number and you pass a string, you can see right away that, wait, there's something wrong in there. There are many different examples of this, and you find them really easily after using TypeScript for a while. I guess a fun little mention here is I wrote this code like 10 years ago. This code gets the URL and it gets all the parameters. So you have like the question mark, and then you have parameters, and you have the AND operator with other parameters. So this code, it read the URL and converted all of that into an object with the properties as the keys and the values for each thing. So basically, I was converting the URL into an object and having access to all the parameters. And then in this code that I wrote, there's an error. There's something that's never going to work, and I never saw that before when I made this presentation, because I tried to find some examples to convert my codes from JavaScript to TypeScript. And when I tried to do this one, I saw this and I didn't notice this before. So basically, I have this parameter on my function called search. And search, if you look on the last line, it's an array of strings because it gets the URL search, gets part of it, and then splits with the AND operator. So I get an array of strings. And here on my line 2, I was comparing my variable, which is an array, to an empty string. But an array or null is never going to overlap with an empty string. So this is not just TypeScript. This is JavaScript. This is never going to run correctly on JavaScript. This is never going to be true. So it's never going to reach this line, meaning line 2 is completely useless here. It simply does not do anything. And I never saw that. And this code is not like something that people didn't see. This code is the third most voted answer to how to get query string values in JavaScript on Stack Overflow. And no one ever fixed or commented about it. Not that I have seen. I checked before this talk. But yeah, like no one saw this silly mistake or no one cared about it. Because it's not harmful, it's just a waste. Another cool thing is that TypeScript told me that this function, sub str, is deprecated. I shouldn't be using this. So TypeScript tells me what I should use instead. So that's really cool too. TypeScript gives you auto imports. So you can use, in the first example, I'm using StackBlitz. It's an online editor. And in the second example, I'm using VS Code. When you type, so in the first example, I'm trying to use a package. I'm trying to use Axios. So if I type Axios, it's not going to find a variable called Axios in this code because I don't have anything else. But it knows that Axios is a type. This variable exists in some package I'm using. And then it detects all the references to that name and then offers to autocomplete for me. So if I press enter in here, it's automatically going to add the import Axios from Axios for me in this code. So I don't have to type import things from things. I can just let the IDE import for me. In the second example, it's a similar case, but instead of using a package, I'm using my own code. So I have another file where there is a function called setFoo, and then VS Code detected, wait, I know this, it's in this file, and then it offers to import that reference to me. So you don't have to type import things from things anymore, you can just let the IDE complete for you. TypeScript gives you go-to definition. So this example, I'm using Lodash and trying to use get. And then if I right click or press Command F12 or Control F12, it takes me to the definition. So when I have a package with types, that's going to take me to the type definition for that function. If it's my own code, it's going to take me to the function definition where I'm declaring the function. TypeScript gives you find references. So in this case, I have a function. And if I right click find references or press Alt F12 or Alt Shift F12, it's going to find every file or every line of code that is calling that function. So in this example, I have just a single file, and then I have a reference on line 19 and 23. So it shows me all the references to that symbol. If I had other files, if this was being exported and I was using this function on other files, it would show me all the references to the other files as well. And so I can see if I'm exporting something and I can figure out if it's being used by something or not. Sometimes you can be exporting something that's not being used at all. And sometimes you just want to find the references to maybe add an extra parameter, or for whatever reason, you can find all the references this way. I guess you could also just search for set foo in your entire project, but doing this way, it doesn't have overlaps. So if you have another function with a similar name, it wouldn't catch that because that's not the same reference. So this is actually only getting the actual references to this function. And TypeScript can be used on small projects too. So a code from me here. Let me find a project I have in JavaScript. So I can try to convert to TypeScript and use the examples in my talk. And then a few minutes later, I can find a single project that I have in JavaScript. So I was actually looking at my folders. I don't have JavaScript code unless I'm talking about 12-year-old code, which I'm not going to share. I stopped using JavaScript, pure JavaScript. Every project I have, even if it's a single file script, I'm going to use TypeScript. And instead of using Node, I can just use ts-node, and that runs TypeScript. So I don't have to worry about compiling anything. I just change from Node to TS Node, and it just runs. I don't have to do anything else. And Ender said, TypeScript is super useful also for little development, right? Because it will just be, if nothing else, it will just help you look up all those methods and all those jQuery objects or the DOM or whatever you're using, right? So you don't have to look up yourself. So in a sense, it can improve your productivity too. So he's saying that with TypeScript, you get all this auto-completion, you get Intellisense, you can just focus on being creative and getting things done. You don't have to focus on going over to the documentation to find how to use things. You can just use things instead, and you can move faster. But even if you're going really fast, even if you're flying, that doesn't mean that you shouldn't care about your code. You have to find balance. So like in the end of the day, the most important thing is to be productive, to deliver value to clients. Like if you watched Melanie's talk, she talked about this. But at the same time, she also talked about this, that you have to keep a certain level of quality on your project. So you don't want to write code that's going to have a bunch of bugs or code that's too hard to work with, because that's going to make you deliver less. That's going to make you less motivated to work on it. So you kind of have to find this balance between going fast, but at the same time, not destroying your project. So I do recommend clean code to at least have this in the back of your mind. Clean code talks about meaningful names, avoid mental mapping, avoid disinformation, make meaningful distinctions, use searchable names, be consistent, don't write comments, and Uncle Bob is watching you. So Uncle Bob is the nickname from he wrote this book. And one last thing is that so find balance. Like there's this bike shed effect. So this is basically you have a nuclear plant that costs $28 million, and then you have a bike shed that costs $1,000. Sometimes you're gonna have discussions that take 45 minutes and they don't matter because it's just $1,000. So you might be talking about, oh, this button is not in the right color. Oh, this button is 2 pixels to the left. Oh, this pixel is bugged, whatever. And that doesn't matter. That's insignificant near a nuclear plant that costs $28 million. And with a discussion of 2.5 minutes, you could solve that problem and avoid like something major. But instead, you care about that button that's 2 pixels off. Like you should focus on what matters. You should focus on the right things. What's actually going to matter in the end of the day, and not about 2 pixels off. So, and a few more things that Melanie also talked about. Don't write cheat code that causes a lot of bugs or make it impossible to deliver new features. Don't over-engineer. Don't make things more complicated than they need to be. Don't focus on trends. And that's about it. So if you like TypeScript, if you like doing shit, then come join us. We are hiring. We are top developers on Coders Rank. We are top developers on Clutch. And we are looking for more full stack developers, top developers, to join our team. So yeah, if you have any questions, let me know.